All right, y'all. One last page of finding angles. And again, hopefully by this point, if you've been watching all the videos or doing all the practice, this is becoming very routine. So without further ado, let's find our reference angle, which again is going to be given to us by the question mark. I'm going to change it to an A, just because I want to. Let's identify the pieces. So we have the 19, that's going to be our hypotenuse. And then we have the 16, that's going to be our opposite. Right. So when setting up the ratios, we have O and we have H. And so we're going to compare the O over H ratio to another O over H ratio, because these ratios have to be the same by rule, because of course these triangles are going to be similar by their angles, by the right angle and the reference. O over H, SOHCAHTOA, that's going to be sine. So we have the sine. We have the sine of our angle, in this case A, is equal to a side length ratio. So going to our actual triangle using A as a reference, the O side is 16. O side is 16, I think that was 16. Here we go. And the H value is going to be 19. Okay. But we have those side lengths, so let's just kill the sine value in order to get the A degrees by itself. Okay, and so if we have, it's gonna take forever. Keeps messing up, board. It's gonna take forever. Okay, so let's try one more time. So sine. Okay, here we go. All right, so if we have the sine value of our angle A, and we want to get A by itself. We just have to apply the inverse sine value, or function, to sine. Because by rule, those will cancel, leaving us just with angle A. Okay, but to get the actual angle value, note that we have to apply the inverse sine value to both sides. Okay, and so we have to apply it to the side ratio of 16 over 19. Okay, so grabbing a calculator, let's decimalize 16 over 19 first. 16 divided by 19 is 0.842. We apply a second sine, inverse sine, and our angle value is around 57 degrees. So we have 57.363 degrees. All right, so reference angle. Okay, we have hypotenuse. Okay, then we have, looks like adjacent. Sweet. All right, so reference triangle, actual triangle, keeping our side-to-side organization nice. Those triangles, of course, going to be similar, so we know ratios are going to be the same. In this case, I have adjacent, I have hypotenuse, so A over H should be equal to A over H. That's only in reference to an angle. In this case, I kept it a question mark. It's a thing I didn't like, but I did it. So A over H, by rule, is going to be cosine. So if we reference the angle unknown, the question mark, the adjacent side is going to be 52. Okay, and the hypotenuse value is going to be 56. Okay, since the only thing we don't know is the angle itself, okay, we now have to get rid of the cosine function. Okay, to get the angle unknown, the question mark by itself. Okay, just like every other example so far, we're going to apply the inverse function to that trig function, because I know I can get those to cancel by rule. Okay, but if I apply to one side, I have to apply cosine inverse to to the other side. That's just basic equation stuff, right? If you do something to one side, you got to do to the other. And so 52, 56. All right, so 52 divided by 56, that's a decimal first. And then we'll apply inverse cosine to that, and we end up with an angle value of 787. And that is actually approximate. All right, so a couple more examples. Oh, look, these are actually kind of cool because we have all the side values here. We have to find this angle value, which I'm going to call y, and we just have to pull a couple pieces. So again, it doesn't matter which ones we do pull, we just need two, and so I'll use the A and the O. So O over A for angle y. It's the same as O over A for angle y. Okay, O over A is going to be tangent. Okay, so using y as a reference, the O side is 76, and then the adjacent side is going to be 57. Okay, so you know now we have to get rid of the tangent as a function, and so we'll apply the inverse tangent. Okay, and that's going to be of tangent of y. So by rule, the inverse tangent and the tangent will undo each other. That are inverse operations. That's what happens. Okay, but if I apply it to one side, I have to apply it to the other. So I have to take the inverse tangent of 76 over 57. Okay, so 76 divided by 57 is about 1.3 repeating. And so I'll take the inverse of that, inverse tangent of that, and my angle is 53.130 degrees. Okay, I'll use my hypotenuse, 97, and let's use opposite. Let's get crazy. All right, so opposite hypotenuse, that's going to be O over H for my reference triangle, and so O over H also for my actual triangle. So if my reference triangle uses angle, the one I call X, okay, so converting O over H, that gives me sine. Okay, so using the reference angle of X, in my actual triangle, my OP, my O, or opposite side, is going to be 72. Okay, then my hypotenuse side is going to be 97. Okay, so we have both side lengths, and so we don't have the angle, so we got to get the angle by itself. In essence, we have to get rid of the sine value, and so we'll apply the inverse sine value, because that's what inverses do. Inverses get rid of something or undo something. Okay, but if I apply to one side, I have to apply to the other. Okay, and so I have to apply it both to the sine of X where X is of course the angle. I must also apply it to the ratio, opposite over hypotenuse, or in this case 72, over 97. Okay, so a function and its inverse will always cancel, undo each other. Okay, so x degrees, 72 divided by 97 is a decimal first, and then inverse sine gives an angle of 47.925 degrees. Okay, that was a little rough with the board like messing up so much. But like these last 3 pages, like all you're really seeing again is like the same setup, just 1 point in divergence. You can't type in sine of x into your calculator. You don't need it anyway because you have both side lengths. But at this point, we know this equation is true. And so if we just solve it for x or solve it for y or solve it for a or a question mark or whatever, then we should be able to get the angle itself. And all we have to do is apply the inverse function. That's what you guys learned like Thursday, Friday, maybe a little bit on last Friday. Oh, I'm sorry, Monday and Tuesday, right before Thanksgiving, which is today is Tuesday. That's the day I'm shooting this. So that's it for this. All we have left are some contextual problems or some word problems. And so I'll chunk those up too, probably do like 1 or 2 at a time, maybe 3 or 4. We'll see how long they take. And we just got to find those and we're done with the review, guys. How exciting is that? I'll see you guys in a minute.